Capacitors. Capacitors, the same as resistors, they come into different categories, either fixed or variable. And the fixed ones also come in two different types of categories, either polarized or non-polarized. In the case of resistors, we discussed that resistors don't have any polarity. You could connect them either way. The orientation of the resistor didn't matter as far as connection. Yes, as far as deciphering the code, you had to have it in a certain direction, which I explained earlier. But as far as the connection in the circuit, it wouldn't make any difference which way you connect them. But with the capacitors, I have here a few different types of capacitors. These are all capacitors. What are capacitors, first of all? Capacitors are shown in a circuit like this. This is a symbol for a capacitor, or like this. It's almost like a battery, but we have these lines as well. Now, this type, when you see this symbol, this is a polarized capacitor. You have positive and negative on them actually written or typed. With this one, you have no polarity. So this is usually negative, that's positive, and this one doesn't have any polarity. What that means is, this type of capacitor, it doesn't matter which way you connect it. With this, you have to be very careful. Not only you can damage the capacitor itself, but you can damage the whole circuit as a whole, and even cause bodily harm to yourself or others. And I'll explain a little bit further in a minute. Capacitors that are polarized or have polarity, positive, negative, like these, we call them electrolytic capacitors. And the way you distinguish the positive from negative pins is if you buy them new and you've got them off the shelf, one pin or one leg is shorter than the other. The shorter one is always the negative one. But you won't always know that, because once you've connected them in the circuit and you've taken them out, or if it's been used sometime, then it's been already cut short. Both of them have been already cut short. So you need to know a better way to distinguish the difference between the positive and negative pins of a capacitor. This is the correct way. Obviously the short and long pin is correct too, but that is not a professional way. You need to know the principle. If you look at these are usually cylindrical shape in a form of a cylinder, and they come in different sizes, from this size, even smaller than this, to massive ones that are used in huge industries, companies, and power stations, and they are huge, and they have special rooms for them. Anyway, one side of the capacitor, one side of the cylinder has these arrows pointing to this pin, which shows this sign negative. This is the negative one, and obviously the other one will be your positive. Capacitors are shown with these symbols and also indicated by C. So the letter C indicates the capacitor in a circuit. You can have numbers of them, C1, C2, C3, and all that, the number of the capacitor. And they're measured in sub-multiples of Farad. So their unit is Farad, but Farad is a big unit. so the size of the capacitor would be huge, which is why you usually find the size that is written on the capacitors in sub-multiples like millifarad, usually small m, capital F. Farad always comes with capital letter F, or microfarad, which is like a U with a big tail. We call it microfarad, and that's a Greek letter which is called mu. So mu, we call it microfarad, millifarad. This is basically, millifarad is times 10 to the power minus 3. That's times 10 to the power minus 6. Next one is 10 to the power minus 9, which is nanofarad. And it goes on to picofarad, 10 to the power minus 12. We have a list of this on our website. You can have a look, and that'll be on your extra curriculum. You can find all these multiples and submultiples for the ease of calculations. So capacitors are shown by this symbol. C is the letter for capacitors. They're measured in farad or submultiples of farad, and they come either as electrolytic capacitors, which are polarized capacitors, which means you have to observe the polarity of the capacitors when you're connecting them, or capacitors like these, and that doesn't really matter which way you connect them. These are non-polarized, and this is a ceramic capacitor. These three are ceramic capacitors, and this is a variable capacitor, same as variable resistors. Variable capacitors also have 3 pins, and this particular variable capacitor is used for tuning, radio tuning. Again, back to this radio, the knob that you tune into a station that you use is basically behind that. If you look, is this capacitor. This is this variable capacitor, which basically by doing this, you're changing the capacitance of the tuning circuit, and you tune into different stations. What's inside a capacitor? Inside the capacitor, you have 2 plates, 2 conductive plates that are in front of each other, and each is connected to their own pin. Whether they're electrolytic or non-polarized, they all have 2 plates in front of each other and an insulator in between, which is called dielectric. Depending on what material is used as the insulator in between them, whatever the material is in between them that's used as an insulator, so they won't cause short circuit, that capacitor is called by that name. For instance, you have ceramic capacitors, which I just showed you. That indicates the insulator in between the plates, or the dielectric, is ceramic. Then we have all sorts of different types of capacitors because of what they've used as dielectric in between the plates. For instance, you have film and paper capacitors, you have tantalum capacitors, polymer capacitors, silver mica, silicon, air gap, and even vacuum capacitors. In the case of electrolytic capacitors, the ones that have polarity and they matter which way you connect them, dielectric is a chemical substance, electrochemical substance that when you connect the capacitors the right way, they start basically electrolyzing and it causes a chemical reaction in between the plates that causes the electrostatic field in between the plates, which is why it's dangerous if you connect them the wrong way around, because you can have the dielectric, in this case the chemical substance, react and cause explosion. It could be a minor or big explosion depending on the size of the capacitors and the voltage. With the electrolytic capacitors also have another indicator on them written, which is called working voltage. For instance, in this case, if I just show you close up, right there it says 50 volts. That is called working voltage. That means the voltage that you apply to this capacitor should not exceed 50 volts or you will damage it. The value of the capacitor itself is written on it, 0.47 microfarad. So it's 0.47 microfarad, 50 volts. That is usually the two important values that you need for the electrolytic capacitors. There's also working temperature written on it. If you're designing an electronic circuit, wherever, depending on where it needs to be working, in which environment, you need to also bear in mind that they have a working temperature that you need to, consider. For instance, the working temperature in this one is -40 to 105 degrees. So it works within that temperature all right. All right, now quickly doing a quick recap on what we said about capacitors. Capacitors come in two different types categorically, either polarized, which are these electrolytic type. They have their own polarities, or non-polarized capacitors, which can come in different shapes and sizes as well, and usually the value is written on them. And the value of the capacitors, either electrolytic ones or non-electrolytic, the non-polarized ones like these ones, ceramic ones, they're all written on them. But when it's electrolytic or polarized, they actually write the unit. So if it's like, for instance, the one I showed you is 0.47 microfarad, it actually says that, it spells it out, microfarad. But with the case of these like ceramic capacitors, in this case, for instance, it says 223. That is 22, the same as resistors. The last digit is the number of multipliers or number of zeros. 22,000, but bear in mind, this is 22,000 picofarad. So it's always picofarad unless it's stated. So whatever the value is written on it, if it's not stated like any kind of indications, like small m or micro or anything like that, then you have to consider that picofarad. Same as this, 3 zeros in front of it, that's 22,000 picofarad. So that's usually in picos, unless it's stated. Other than that, usually other ceramic type polymer, tantalum, those kinds of silver mica, all those kind of capacitors are actually stated, the value stated on them is in picofarad. Variable capacitors also, the value is stated on them. And some capacitors come in color coding, which is exactly the same as color codes of resistors. And again, that is in your course content table. You can find that in full detail. So what do capacitors do? What is their application? Capacitors have a few different major applications in electronic circuits. The first one is storing charge or electric charge or electricity, basically. The store energy. When you apply voltage here, positive, negative, all the charges of negative goes on one plate and positive goes on the other, so you have a charge of electricity stored in that capacitor. Especially in the electrolytic ones, they use those for storing voltage or electric charge. And what do they do with that? They use it for flashing circuits, for flashing lights, for stable or monostable circuits, for signal generators, for all sorts of things, and that is why they need this storing of energy, and so they can release that in a shorter period of time to get a massive amount of energy released into, let's say, a light bulb, and that gives a massive light suddenly for cameras, for those kind of things. That's just an example. Another application of the capacitors is for filtering unwanted noise, unwanted signals or noise that you don't want from one end of the circuit to the other end. You want to filter it out. The capacitors are there to do that job. What they do, capacitors basically conduct AC. AC passes through a capacitor, but DC, that is a fixed voltage, which we discussed in the previous module, doesn't go through from one end of capacitor to the other, which is why you use these for filtering. And by filtering, I mean you remove unwanted noise from one end of the circuit to other end. Examples can be in radio tuners, same as I just mentioned in that radio again. So this variable capacitor is actually for tuning, but there are other fixed capacitors here that are used, polymer capacitors, electrolytic capacitors. These are used, some of them for filtering and some of them for charging and discharging energy into the circuit to cause that amplification that you need in the amplifier part of the circuit. But keeping it simple, all you need to know is capacitors are used either for storing charge and energy, electric energy, or filtering. Basically, you can let the AC through the capacitor and stop the DC, so the DC doesn't interfere from one end of the circuit to the other end. That's two main applications of capacitors. Another application of capacitors is they can act as power factor correction components. I don't want to get into too much details of that at this stage. We talk about that again when we get to power and energy, where we'll be talking about saving energy, and capacitors will come into that discussion. At the moment, two major applications of capacitors are filtering or letting AC through and not DC, stopping DC to go through the capacitor, and storing energy. I just wanted to give you a quick introduction to the course and myself, so you can put a face on the name.